Hello friends, welcome back to my YouTube channel that is all about structural analysis and design. So today we will go through the one of the important leveling aspect to find out the reduced level of different points is by height of instrument method. So this is very usual method we go for finding out the reduced level of different levels. Okay, so we will go through what is meant by height of instrument method, and also we will solve one numerical based on this height of instrument method. So in this method, height of instrument is calculated for each setting of the instrument by adding backside to the elevation of the benchmark, that is also known as BM. So if you want to find out the height of instrument, so what you have to do is the RL of the benchmark you have to add with the backside. Okay, second point you have to remember is the elevation of reduced level of the turning point is then calculated by subtracting the height of instrument, that is HI, from the foresight. So whatever you have calculated the height of instrument with the first benchmark, then you have to find out the reduced level for the second point by subtracting from the HI. Next, if there are some intermediate points, the RL of those points are calculated by subtracting the intermediate sides, that is IS, from the height of instrument for that particular setting. So I have written this wordings are a little bit difficult to understand, so I have written these wordings into these formulas. So HI, if you want to find out, you have to do RL plus backside, and if you want to find out the reduced levels, then what you have to do is height of instrument minus foresight, and if there is any intermediate sides in between, then the formula becomes RL is equals to height of instrument minus IS. So these 3 points you have to remember. So same points I have converted into this formulas. So if you remember this 3 formulas, then it is very simple to calculate the reduced levels of different points through height of instrument method. So we shall take up one example for clear understanding this height of instrument. So the following consecutive readings were taken by a 4-meter leveling staff on a continuously sloping ground at 30-meter interval. Okay, so these are the readings at different points. Okay, the first reading is 0.585 on point A, and the last reading is 3.016 on B. The elevation of A, okay, the starting point of the survey, the elevation of point A is 520.450 meters, and also you have to apply the usual checks. So whenever these readings are directly given, the students will be in confused state. So which column you have to enter these particular values. Okay, so they have not mentioned the change points in this particular problem. So what you have to do is I have drawn one figure so that you will be understanding this clearly. So this is your A point, starting A point. Okay, and the survey is ending at this particular B point. So the setup, the instrument has been set up here. Okay, so this is nothing but tripod, and it has been set up at this particular point, and the first reading they have taken here 0.585 on A. Okay, like this they have went continuously 0.936, 1.953, 2.846, 3.644, 3.938. But if you look carefully, there is sudden decrease in this particular staff readings. Correct? After 3.938, it is getting suddenly decreased 0.962. Then again it is getting increased till 3.844. But again suddenly it is decreased to 0.956. So here is the twist. So from these particular readings, you have to understand that it is change point. So for clear understanding, I have drawn this figure. The first will be the back side, then 0.936, 1.953, uniformly it is getting increased. Correct? Why it is increasing? Because the ground is sloping. As you move towards the B point, okay, the staff is only 4-meter interval. If it was 5-meter interval, then again you could have taken here some points for finding out the RLs. But the leveling staff is of 4 meters, so the maximum reading from this particular setting of the instrument you can take is 3.938. If you go beyond this particular point, what will happen is the line of sight will not bisect the staff. Okay, it will go above the 4-meter interval, so you cannot take the staff readings. So from that particular point, what you have to understand is there is only one way to proceed the surveying, that is you have to change this instrument station. Correct? So you have set up this instrument here and you have taken these 5 readings, but the 5th reading, sorry, 1 2 3 4 5, but the 6th reading is not possible to take. Why? Because the staff is only 4-meter staff, and the line of sight is not getting bisected to that particular staff. Then you have to change the instrument position. So from here you have shifted the position here, and this is known as change point 1. You can mention here change point 1. Correct? So again the your surveying starts. So you have taken 1.035, 1.689, 2.534, 3.844. But again, if you go beyond these 4 points, if you keep the staff here at 5th point, the line of sight will not bisect that particular point because the staff is of only 4 meters. Then you have to understand that you have to change this instrument point and you have to shift to the next point so that the surveying is carried out. In that particular case, this will be change point 2, CP2, right? And like this, the surveying or leveling part ends at this particular point B. I hope you have understood, right? So the next important point is to enter these readings in a field book. So this is a standard format of the field book. Correct? So first the column you are having the station, so that is first station is A. Second column is all about distance. Third is back sight, which I denoted as BS. Next is intermediate sights, 4 sights, height of instrument, reduced level, that is RL, and the remarks you have to write down if at all remarks are there in this particular problem. Okay, so the surveying part starts from station A, which is at distance 0 meters. So backside, always remember whenever you are doing a leveling experiment or a problem or surveying, what you have to keep in mind is the leveling starts with the first reading writing in BS column, that is backside column. Why you are taking backside means, you can refer this again figure. You have set up the instrument here, you are taking the backside. Correct? So the benchmark is given here 520.450 at A. Correct? So you have to backside this reading, right? So you have to write down 0.585 on backside column. So you can write down here 0.585. Then RL they have given at 0.8, 520.450. So remember this first formula which I have mentioned here, HI is equals to RL plus backside. So RL is known, backside is known, directly you can find out the HI by adding it. So what will happen is 521.035. 521.035 will be your first height of instrument for that particular setup, right? So next, you are not changing any instrument position. So whatever readings till 3.938 you are getting, right? Sorry, till 3.644 you have to write down in IS column. Okay, one by one you can write down 0.936, 1.953. Next is 2.846. Next is 3.644. Okay, till here there is no problem in entering this field book. What happens now is, again we'll get back to this figure, right? 3.644 till here you have written in IS column. Okay, this fifth reading is also visible from this position, 3.938. But what happens is, this after this staff reading, the instrument position is being shifted. So this is the last reading, okay, from this particular instrument. So this last reading you have to write down in foresight, right? Foresight column. Okay, so 3.938 I will be writing in foresight column, that is at 150 meters, 3.938. And after shifting this instrument, correct, after shifting this instrument, then again you are taking the reading at that particular staff point. Okay, remember, you should not lift the staff until and unless the backside is taken from the changed position of the instrument. So when you lift this instrument, this staff should be there in that particular position. After setting up this station or this instrument station at next point, after doing the temporary adjustments, then you have to take the backside on this particular staff. So remember, don't remove this staff from this particular point. So 0.962 will come in backside column. So you can write down in backside column 0.962. Right? Then again you have to write down in IS column values, 1.035, 1.689, 2.534. Then again the instrument is being shifted. Okay, so 3.844 is the last staff reading from CP1. So you should write this in foresight column, 3.844. Right? After changing this instrument position at CP2, then you should not lift this staff and you have to take down the backside from CP2, that is 0.956. Correct. So then the next intermediate site reading 1.579, and the last reading. Okay, so like the starting of the leveling instrument surveying, what I've told is the first reading will be on backside and always the surveying ends at the foresight. Okay, so the last reading will be on foresight, 3.016. Correct. So this is the entry of the staff readings in BS, IS and FS columns. Okay, so the first point you have calculated, that is HI 521.035. so remember, the HI will not change till this 120 meters. Okay, right? So only the reduced level you have to find out at 30 meter, 60 meter, 90 meter, 120 meter. This HI will be remaining the same. Okay, because you should not get confused. Then I will write down this whole 521.035 till here, 120 meters. Be clear till here. Okay, the height of instrument is not changing till 120 meter distance, but the reduced level will be changing because it is continuously sloping ground. So the RL will be slightly getting reduced from this 30 meter interval. Then according to this formula, correct, according to this formula, RL is equals to HI minus FS, right? So the sample calculations I have shown in the next slide. Here I have mentioned. Okay, so this was at A. Okay, HI we have written 520.450 plus 0.55 the backside, though the HI will be 521.035, which we have written. Okay, so next RL, 30 meter RL, if you want to find out, what you have to do is simple thing, RL is equals to HI minus IS. So whatever IS is there in 30 meter interval, just you have to minus it from the HI. So the RL will be 520.099 meters at 30 meter interval. Okay, so this 521.035 minus 0.936, you will be getting the reduced level as 520.099 meters. So write down here. .099 meters. So again you have to take this HI 521.035 minus 1.953. So you will be getting 519.082. 521.035 minus 2.846, 518.189. 518.189. 521.035 minus 3.644, you will be getting 517.391. Okay, the twist is now at the point 150, right? So you have to find out HI as well as RL. What we'll be doing is, so we will finding out the RL first, right, with the same HI, because the last reading was from foresight. The last reading is foresight from that particular instrument station. So 521.035 minus FS, the third formula which I have shown in the first slide. 521.035 minus 3.938, correct? You will be getting 517.097. 517.097. That will be your change point 1, CP1. Now what you have to do is, like how we have done for the station A the calculation, same thing you have to repeat now for change point 1. So take this RL 517.097 minus this backside 0.962, you will be getting the new HI. So that is nothing but 518.059. 518.059. 518.059. This is the new height of instrument at change point 1. Okay, you can see here, just compare this figure. The height of instrument at point A was 521 and at CP1 is 518, right? So this is at higher position, this is at lower position. So you can see the difference, right? So this is at lower level. So the RL is height of instrument is 518.059. Then again proceed with this same calculation. 518.059 minus 1.035, you will be getting 517.024. So you can write down here same HI 518.059, 518.059, 518.059. So you can write down 518.059 minus 1.689, you will be getting 516.370. 518.059 minus 2.534, you will be getting 505.525. So again there is change point. So what you do is, as usual, 518.059 minus 3.844, you will be getting 514.215, right? Take this RL plus this backside, you will be getting new HI, that is 515.171, right? The HI will be same here, 515.171 minus this IS, you will be getting 513.592, and the last reading is in FS, so 515.171 minus 3.016, which will be getting 512.155. right? So the change point is here. So wherever there is change point, you will be getting the staff readings in backside as well as in foresight. So you can write down remarks is CP2. So this is the entire table you have to fill for this height of instrument method. So I have shown here some readings. If you are getting confused, you can go through these readings. Some 2-3 readings I have shown. You can just go through these readings, and also they have said to apply the checks. So this arithmetic check for this height of instrument method is sigma bs minus sigma fs, that is summation backside minus summation foresight, is equals to, should be equal to last RL minus first RL. So if you do all the summation of backside, so all the here summation of these 3 values backside and all the summation of foresight, if you do, you will be getting the values 2.503 for summation backside, and summation foresight is 10.798, last RL was 512.155, and the first RL was 520.450. You should be getting the same values. Don't worry about this minus sign. Minus sign we are getting because the ground was continuously sloping, so the last RL will be the reduced one compared to the first RL. So you will be getting this same values. If you get the same value for the check, then you can just conclude your problem is correct. Okay, so I hope I have cleared all the doubts regarding the height of instrument method. Okay, I will be coming up with the next video, which will be focusing on rise and fall method, another method which is used to calculate the reduced levels at different points. If you like my video, please share it, and don't forget to subscribe all about structural analysis and design, and also press the bell icon for the latest notification of the civil engineering and structural engineering videos. Thank you guys.